To start this unit on circles, we're going to cover some basic definitions today, and then the last page of your notes we're going to save to do together in class. So this is just some of these definitions here, and I'm not going to probably use a lot of the examples and formulas, just one or two in here. We might go back and fill some in later in the unit. Okay, so a circle. We all know what a circle is. We defined it probably on the second day of school. It's a set of points in a plane that are equidistant from a fixed point, which is the center of the circle. So we have our diagram here, and here's our circle, center O. We call this circles O, and we have a couple of formulas that go with it. The formulas we do know are the circumference, C is equal to 2 pi r, and the area is equal to pi r squared. And as we've always done this entire year, we denote the circle by the label in its center. The radius is something that we also know. It's a line segment drawn from the center to any point on the circle, so we know all radii in a circle are congruent. There's radius r, and I think we'll write that down. So my board right here is a bit small. Let me read that to you. It might not look right. All radii in a circle are congruent. That's supposed to be an E. It looks like an arc. Okay, a chord might be new. A chord is a line segment which connects any 2 points on a circle. Any of them. So a chord is a line segment that begins and ends anywhere on the circle. Now the special chord, or a special chord, is the diameter. A chord which passes through the center. So that is the longest chord in a circle. It passes through the center, and we know the diameter is 2 times the radius. Now we have a couple other special lines in a circle. A tangent is a line or ray that intersects the circle at exactly 1 point. So it just sits on the edge of the circle like that, and that should just be 1 point where it intersects. It's hard for me to draw it here, but that should just be one intersection point. And a secant passes through the circle and intersects the circle at 2 points, so it's like an extended chord. So a secant goes beyond the circle endpoints, though. If you compare the two, a chord begins, and that's supposed to be touching the circle but not going over it. It starts and stops on the circle itself. A secant goes through the circle. Okay, a central angle that has its vertex in the center of the circle, and its sides are radii. So a central angle, basically, its vertex is in the center, and its two sides are the radii. We can use the symbol theta. That's hard for me to draw in that little bitty spot. I don't have a formula yet to share. We will later on, but then we can say that's angle theta. Basically, that's the central angle. An inscribed angle has its vertex on the circle, and the sides are chords. So that's different than the central angle. The central angle has its sides as radii. An inscribed angle has its sides as chords. And we can label it, if I draw one, if I say this is, let me draw one over here, a circle and an inscribed angle, and we have A and B and C, that would be angle ABC. Just like before, the vertex is the center letter. Now an arc is probably new for you. An arc is any part of the circle itself. So an arc is the curved area that's part of the circle. And the symbol, if this is A and this is B, the symbol for an arc, instead of a line segment, it would be an arc like that. Now the sum of the arcs of the circle, they're all going to add up to 360 degrees. So arc length is measured, in this class, arc length is measured in degrees, just like angle measurement is. So let's look at the next thing here. The intercepted or subtended arc. Here's what that is. That's an arced form by the endpoints of each side of an angle, and it includes all interior points of the angle on the circle. So the intercepted arc, if I have a central angle like that, the intercepted arc is the arc that the angle creates. and again, if this is A and this is B, that would be arc AB. There's the symbol. And if I have an O in the middle, there's arc AB and there's angle AOB. Angle AOB subtends arc AB. A semicircle is next. A semicircle is half a circle. We do have some formulas here. We know the formula for the area of a semicircle would be 1/2 pi r squared, and the formula for the circumference, instead of 2 pi r, it would be pi, half the circumference would be pi r. And then if you wanted the perimeter of that, it would be half the circumference plus the diameter. Okay, getting back to our arcs. A minor arc is an arc with a measure less than 180. So if I have this guy here and he's less than 180, A, B, C, that's a minor arc. And we label it just as arc AC. A major arc is the other one. It's the arc that measures greater than 180 and less than 360. So if I have this again, A, B, C, I usually need another point out here to denote that it's a major arc. Otherwise, it's a minor arc. So the major arc here is going to be arc A, D, C. So it typically takes 3 letters to name a major arc. Okay, the next one we've talked about before, concentric circles. Those are circles in the same plane with the same center but different radius. So they share the same center. That's the big deal. So this could be radius 1, this is radius 2. But they both have the same center. An inscribed polygon, that's a polygon whose vertices lie on the circle and whose sides are chords of the circle. So just like ABCD here, ABCD is inscribed in the circle. And circumscribed is one where all the sides are tangent to the circle, so it's outside of the circle. And finally, we have 2 more definitions here. We have the degree measure of an arc, or a theorem actually. We're going to define it. The degree measure of an arc. We're going to define that as being equal to the measure of the angle that subtends the arc. So equal to the measure of the central angle. The measure of the central angle. So it's the measure of the central angle that subtends the arc. They are equal in measure. And then that's if the that's a central angle. But the measure of an inscribed angle is equal to half the measure of its intercepted arc. And you're going to see all of these in the next lesson. We will get back to these again and talk about arc measures and angle measures. So this is just a brief introduction to some of the terminology and definitions that we're going to be using in this unit. And the last page of your notes we're going to work together in class.